So let's take a look at how to integrate secant theta if you don't know the special trick. So the first thing to do will be to take a look at secant theta as 1 over cosine theta. And then d theta is still right here. And this didn't help yet, but perhaps I will multiply top and bottom by cosine theta again. And the reason I want to do this is because now on the bottom I will get cosine squared theta. And I can use an identity for that. So this is going to be cosine squared theta on the bottom right here. And I know cosine squared theta is the same as 1 minus sine squared theta. So I will write it like that. This is cosine theta over 1 minus sine squared theta, and then d theta. And the reason this helps is because now I can do a u substitution. If I take u to be equal to sine theta, then du will be cosine theta d theta. And that's right here. So basically, this is going to give me the integral of 1 over 1 minus, and then the sine squared theta is going to become u squared. And then this is my du. And now for this, I will have to do factor the denominator and do partial fractions. So this is going to give me 1 over, factor that, you get 1 minus u times 1 plus u. That's a typical difference of squares. And now, to do the partial fractions, I'm going to put down two fractions. And I know that the denominator here is going to be 1 minus u, and the denominator here is going to be 1 plus u. And so I'm going to take this factor, set it equal to 0, so that means that u has to be 1. So over here I will cover this up and put u equals 1 into the rest. So put u equals 1 right here, I get 2, but don't forget you still have this 1 on the top. So my numerator here is going to be 1 over 2, 1/2. And then for this one, I have to let u equal -1 so that this factor equals 0. Then I will cover it up and put -1 into the rest here. So put -1 in here. I have 1 minus -1 is going to give me 2, but I still have the 1 on the top, so this is also going to be 1/2. And now I'm ready to integrate. So integrating this first term, 1/2 is like a constant multiple, and I'm going to get natural log, absolute value of the denominator, 1 minus u. But don't forget, the derivative in here is -1, so to cancel out the chain rule I have to be sure to divide by -1. So I will just put down a negative sign right here. And then for this part, I'm going to get 1/2 natural log absolute value of 1 plus u. Make that a little better. And here the derivative of the inside is just 1, so I don't have to worry about that. And now I will put u back. U is sine of theta, so I will replace all these u's with sine theta, and perhaps I'll just do that. This is -1/2. Actually, perhaps I will factor out the 1/2 from each term, so this is going to give me, let me put this down in the front here, 1/2 times negative natural log absolute value of 1 minus sine theta plus, and I factored the 1/2 out, so this is going to give me natural log absolute value of 1 plus sine theta. And yes, we're done right here, so if you like you can put down plus c and say this is the result of the integration. But this is not the standard result. So what I'm going to do now is rearrange this a little bit. Try to turn this into the standard result that we like to use for integral of secant theta. So this is going to be 1/2. I have in here a difference of natural logs, right? I have this one minus this one. So I can write that as natural log of a quotient and the inside is going to be this over this. So this is going to give me natural log absolute value of 1 plus sine theta over 1 minus sine theta. And I'm going to multiply by the conjugate of the denominator on the top and bottom. So I'm going to multiply this by 1 plus sine theta on the top and on the bottom. So let me put down some parentheses here just to clarify. And then now I will close the absolute value. So this is going to give me 1/2 natural log absolute value. On the top, I'm just going to write this down as 1 plus sine theta squared. I'm not going to expand the binomial. On the bottom, I have factorization of a difference of two squares, so it's going to give me 1 squared minus sine theta squared. And now you could go the other way with the identity. I know that 1 minus sine squared theta is the same as cosine squared theta. So this is 1/2 natural log absolute value 1 plus sine theta squared over cosine squared theta. And now I have, in this fraction, the numerator and the denominator are both squares. So I can write this as the square of a fraction. So this is going to be the same as 1/2 natural log absolute value of 1 plus sine theta over cosine theta, and then squared right here. So, to square the fraction, you just square the top and you square the bottom and you get this. Alright, now I have this 1/2 in the front. Remember, a natural log of b, we can use log property. I can take the a and bring it to the exponent right here, and it will give me natural log of b to the a. So I'm going to do the same right here. I'm going to bring the 1/2 up right here, and you will see that the 1/2 will cancel with this 2, because we would multiply the exponents. We have a power of a power, and they would cancel. And I'm just left with natural log absolute value of 1 plus sine theta over cosine theta. And now I will just divide natural log absolute value. I will do 1 over cosine theta is secant theta, plus sine theta over cosine theta is tangent theta. And this is the standard result for the integral of secant theta.